Okay, this next lesson is going to look at what happens to the area and perimeter when we start changing dimensions, meaning what happened to the area if we cut the base in half or doubled the height, things like that. So let's look at this first one, and you'll start to recognize a pattern, and then I'll show you a shortcut that makes this super quick and super easy. So let's go ahead and label our triangle. So A is at 1, 1. B is at 6, 1. And C is at 3, 5. Okay, to find the area, remember we need two things. We need the base and the height. Well, your base is easy because we can count it. The height is perpendicular. We can also count it because those are perpendicular lines and they're vertical and horizontal. So we know if we count our base, 1, 2, 3, 4, 5, we have a base of 5 and a height, 1, 2, 3, 4, a height of 4. So if we're working with triangles, we know that our formula is base times height divided by 2. So a base of 5, height of 4, 5 times 4 divided by 2, so 20 divided by 2 gives me 10. Okay, so that was my original. Now they want us to say, okay, well, let's take that same triangle and let's cut the base in half. So if we cut the base in half, our base is now 2.5, and our height stays the same as 4. So if we multiply 2.5 times 4 divided by 2, that's going to give me an area of 5. So here's our new, here's our original. If we take our original and divide it by the new one, nope, we got to flip it around. Sorry about that. Take your new over the original and simplify. Look what happened. The base was halved and so was the area. So we only changed one thing, okay? So when you are changing only one dimension, okay? So right here, I want you to write dimension, abbreviate that, times factor. That means the area gets multiplied by that same factor. So we changed the base by 1/2, and the area was also changed by 1/2. So you could have done that if you'd have known that the original area was 10 and you knew that rule, then you would automatically know that it was 5 because it was cut in half. So now let's look at the next section. What happens if we start to change more dimensions? So if we have a length of a rectangle is 8 and the width is 3, describe the effect on the perimeter and area if both dimensions are multiplied by 5. Well, right now we're not even going to worry about perimeter. We're just going to concentrate on area. Okay? So if we do area of a rectangle, we know that formula is area is length times width. So my original, my length is 8, my width is 3. So if I say 8 times 3, that gives me an area of 24. And I'm going to put an O there for original. They want us to take both dimensions and multiply them by 5. So now my length is now 40 and my width is now 15. And if I multiply 40 and 15, that's going to give me 600. And so I'm going to put N for new. Remember, we take new divided by original. And if we were to divide that, we would actually have 25. Well, what is 5 squared? 5 squared is 25. We multiplied both dimensions by 5. So think of it like this. Here's my formula. If I change my width by 5 and my length by 5 and my width by 5, 5 times 5 is 25, I got the same answer. So it says describe the effect. That means it got 25 times bigger because we changed our length by 5 and our width by 5. So now let's just look at the next one. And again, we're not going to worry about circumference. We're just going to worry about area. Let me show you the kind of shortcut way. So it says the radius of a circle is 3 inches. Describe the effect on the area if the radius is multiplied by 3. We go back to our formula for area of a circle, and area of a circle is pi r squared. We know if we square something, that's multiplying by itself. So when you're doing this trick, go ahead and write it as pi times radius, because that's the same exact formula. Well, if they want us to change the radius by 3, then we would change this one by 3 and that one by 3. And so our effect would be that it got 9 times bigger. That's all you have to do. Write out your formula, write the change above it, and that's your answer. So if I go back to this first one where we only change one dimension, and I go back to my formula here, area equals length times width. Base times height divided by 2. We're working with a triangle. And it said to cut the base in half, and I put my change above. Well, I'm only changing one thing, so that's why the answer stayed the same. With the other two down here, we were changing both dimensions, and so that's why it got bigger and changed. If you look here, when you change both of them by the same thing, and you look at this one here, well, what's 5 times 5? 25. What's 3 times 3? 9. So could we say here that all we have to do for area is take our scale factor and square it? So if we changed them both by 4, we know that it would get 16 times bigger. If we change it by 2, we would know it got 4 times bigger. Do you have to remember that? No. Using this trick with the formula always works. And so I'm going to show you a few more options here. So let's go back here to the next page. All right, so the next one says, what change will make the area of a square 25% of the original area? Well, this one's kind of working backwards, and we know 25% as a fraction is 1/4, okay? We are talking about a square, so remember formula is side squared, but we want to list those out. So we will say area equals side times side. We're trying to figure out what would make that equal 1/4, not 1/2. So what times itself would give you 1/4? Well, if I multiply 1/2 times 1/2, that would equal 1/4. So we would know that the change that we would have to make would be to change the dimensions by 1/2. All right, the next one, we have a rhombus has a diagonal that is 4 and a diagonal that is 5. Describe the effect on the area if the shorter diagonal is doubled and the other is tripled. Well, you can work this one out and figure out the change yourself, or you can use the formula like we've been talking about. So the formula for a rhombus is area equals 1/2 diagonal 1 times diagonal 2. Well, if they want us to change one diagonal and double it, and they want us to triple the other one, well, all I have to do is multiply 2 times 3, and I know that it is going to get 6 times bigger. That's all you have to do. All right, so now what I want you to do is pause the video, and I want you to try the next 3 on your own. And I'm going to work through these, and when you're ready, click play, and you can see if you did it correctly. So the first one is a rectangle. We're just going to double the height, so I should have used the other formula, which is fine. If you use length times width, it didn't matter. We're going to just change the height. So we know because we only changed one, the effect would just be times 2. Okay, next one is a square. So always pay attention to what shape you're working with first and write that formula down. So area of a square is side squared, so side times side. They want us to change the area by 1/4, which means it's not 1/4 over the s's, it's what equals 1/4. This is a lot like this question up here. It's basically the same exact answer. So it should be times 1/2 because 1/2 times 1/2 gives you 1/4. And the last one here, parallelogram. So area equals base times height. They want us to double the height. And they want us to multiply, base is doubled. The height is by 5, and so if we multiply those, we would know we would get times 10, and so it would get 10 times bigger.